The box below is a 4-bit synchronous counter with parallel load. What is the first count after a load signal? What is the last count before a load happens? Express the value of the count as 4 bits in the order of Q3, Q2, Q1, Q0. Okay, these are actually pretty easy, so you want to hope that you get one of these. So you'll write Q3, Q2, Q1, Q0. And when you load, that's just the bits going into D0, D1, D2, D3. So Q3 would be 1, Q2 would be 0, Q1 would be 0, and Q0 would be 0. So that is the answer to what is the first the first thing that's loaded. So all I did was just took these numbers here, these numbers here, 1, so D3, Q3, D2, Q2, and so forth. Now, to see when it's going to stop, you look at the load and you see what's going into the load. And what's going into the load is the AND of Q3 and Q1. So I'm just going to make a little note of that. So it's the AND of Q3, well, Q1 and Q3. So when that is true, when Q1 and Q3 is true, then it's going to load again. So it's going to count until we get to that condition. Well, I can count, even in binary, I think I can, and we can do that, but we actually can know what the condition is going to be because it's the condition when Q1 and Q3 are both 1. Q1 and Q3 are both 1, and the others are zeros because it's going to be the first time that happens. So there are other times when Q3 and Q1 would be both 1, but as far as counting goes, it would happen after you got there. So let's just go ahead and do some counting. So the next thing, if we were to count 1, 0, 0, 1, 1, 0, oh well, and then we already get there, 1, 0, 1, 0, and that's it. So what you're going to be looking for is the smallest number that meets that criteria, and that'll be where the other digits have zeros. So this is the first, and this is the last. Okay, so now that we've seen that, the next part is going to be pretty easy because now we're just doing it the other direction. Okay, so we are going to construct a counter. I'm going to try to be fancy here. Dangerous. Worked. Okay, I know, that's like small pleasures. All right, and so we have enable D0, D1, D2, D3, load, clock, output carry, which we're not using. The output carry is only what you would use if you were stringing together more than one counter. Like if you wanted, this is a 4-bit counter, if you wanted an 8-bit counter, you would use the output carry to connect two 4-bit counters, Q0, Q1, Q2, Q3. Enable, we'll put a 1 on enable because we want it to be enabled. and we want it to count from 0, 1, 1, 1 through 1, 1, 1, 0. Now remember, we're labeling these as D3, D2, D1, D0. So that's 0, 1, 1, 1. So we'll have 0 going into D3 and 1s going into the others. So that's how we're going to set it up to load. Can y'all see that okay? Okay. And then we want it to stop when it gets to 1, 1, 1, 0. So we want it to stop when 1, 1, 1, 0, when D3, D2, and D1 are all 1. So we'll have the AND of D3, D2, and D1. So I'm just taking the AND of where they're all 1s. Okay, questions on that one?